Hello third year, it's Mrs. McInnes here. Today's lesson is going to be all about using our knowledge of Pythagoras and working with what's called circle geometry. Okay, so essentially your learning intention for today is to be able to calculate the length of a side in a triangle that is contained within a circle. Okay, so our kind of success criteria breaking this down is obviously we have to know our Pythagoras theory. We also now need to be able to identify two new kind of parts of a circle, which is going to be what's called a chord and a perpendicular bisector. And then we're going to look at applying our Pythagoras theorem to various kind of problems that involve a triangle that's within a circle. All right. So what we're going to do to begin with is I'm going to talk to you about these new parts of a circle, which is your chord and your perpendicular bisector, okay? Now they're very simple kind of concepts, okay? The first thing I'll show you is what's called a chord. Now, a chord is any line that joins 2 points across your circle, okay? So this line here, for example, this would be a chord, okay? Now, it can be joining up any points across your circle, any 2 points across here, any of these lines, these are all chords, okay? It doesn't matter where it's placed, it's just across your circle, joining up 2 points across the circle. So, that first one is quite straightforward. The second one is what's called a perpendicular bisector. Now, you can see there, I've flipped that ruler around to 90 degrees against the straight line that I drew down the bottom. That is the exact definition of perpendicular. If two lines are perpendicular, they meet at 90 degrees, okay? So these two lines here meet at 90 degrees, so that would be a perpendicular line through my chord, okay? Now, perpendicular, like I've said, means that you have a right angle between your line and the line that it crosses, and that would be on both sides there. The other part of the name of that, a bisector, means that you're cutting that line into two equal parts, okay? So perpendicular bisector is a line that cuts another line equally into two parts and meets at a right angle, okay? So this line here would be your perpendicular. I have to excuse that terrible writing. Bisector. Writing on this iPad is a little bit tricky. So, perpendicular bisector. So what we're really going to do here today is now look at how this applies to questions where we can use Pythagoras, okay? Now, what you've got in your perpendicular bisectors, that is also a diameter, okay? And that also means that you could also cut that into two from the centre of your circle, and you could also say that you can see your radius there, okay? So, for example, if I was to draw just down there in red, that would be a radius, okay? Now, if we're solving a problem with Pythagoras, what we need is a right angle triangle, and you can actually build in a right angle triangle now that you've got those two parts put onto the diagram. So your perpendicular bisector kind of gives you one side. I'll draw it in green. So this side down here is one side of the triangle. Your chord across here, that obviously gives you another side. And then by drawing in this radius over here, because that is a radius, that is the centre of the circle out to the edge, that now forms a nice little right angle triangle. And now if I had two lengths, I could fill in the third one by using Pythagoras. And that is all what the work today is going to be about, is these types of questions, okay? So I'm going to do 3 examples with you. I'm going to start off really simple where you can very clearly see there that you've got your right angle triangle within that circle. You can see it a mile away, it's very obvious, but let me just run through the different parts. So along the bottom here in yellow, that would be your chord, okay, joining up across the circle 2 points. In green, right down the middle there, you've got your perpendicular bisector, okay, so that is cutting the yellow line into two equal parts, and it's also meeting at a right angle. So that then sort of forms your right angle triangle here out of these 3, all right? Now really that should be very simple to see the triangle. So now when we're being asked to find this side here, this side that's lettered as D, we can go ahead and fill in our formula. Now that is a short side in the triangle, okay? We should be able to identify that now without any issues. So we're going to do subtract, so 7.5 squared minus 6 squared. So if we fill in our values, 7.5 squared is 56.25 and your 6 squared is 36. So that's going to leave us with 20.25. And then we always have to remember to square root that last answer because that was D squared, not D. So we want to do square root of 20.25, which gives us 4.5 centimetres for D. Alright, so the Pythagoras calculation we all should be fine at by now. You should be feeling pretty confident about that now. Now it's just going to be kind of applying the knowledge I'm showing you now of finding the triangle within the circle and finding those sides. So example B, kind of similar, just a slight kind of change in terms of what you're told. So again, across the bottom here in yellow you've got your chord, okay. In green, right down the middle, you've got your perpendicular bisector, so that's cutting that yellow line in half and meeting at a right angle. And then obviously by adding in a radius, we've got our little right angled triangle here in red. Okay, so what we now need to do is say, well, I've got this side here I'm being asked for. I've got the 4 on this side, but I need to know this side down the bottom. Now that 12 is the whole chord. If your chord has been cut into 2 by your perpendicular bisector, that would make this side alone just 6. And now you can go on and do your Pythagoras calculations. So again, it's another little right angled triangle with 2 of the 3 sides. So we should be fine at recognising it's Pythagoras. This time the side that's missing is a long side, so we're going to square and add. So we've got 6 squared plus 4 squared. So that's going to give us 36 plus 16. And then we're going to add, because it's a long side, so 52, and then do our square root of 52. So if we do square root of 52, we get 7.2 centimetres. Okay. Now, the last example I'm going to do, I've tried to make it look as similar as the ones in the booklet that you'll be doing today and tomorrow. Now, the first 2 examples that I did, the lengths of the sides were directly onto the diagram, as was the right angle triangle. Now, the ones in the booklet are not as fully annotated as that, and what you will have to do yourself is fill in that information on the diagram. So the questions are going to ask you to make a sketch of the triangle and the circle that it's inside and fill in the values so that you can see the way that I did with the different coloured pens. You can see where the triangle is. So let's do the same here. This is how you would do the questions that you're doing today, the same way that I'm going to do this now. So we're told in the written section here that the diameter of this circle is 22 centimetres. So what we can do is we can start by saying, well, there's my diameter down the middle, and that is 22 centimetres. Try and make this sideways onto the screen, so 22. Now, because you're told the diameter is 22, what you also know is that your radius would be half that, which is 11. So you might want to jot that down, it might be useful. The next thing you're told is that the length of the chord AB is 12. So you could also fill in across here, I'll try and write it sideways, that you've got 12 centimetres on that side there. So we're now looking for, where's the triangle, okay? Now your triangle will always be made up of your chord and your sort of perpendicular bisector. So actually in this case you've got your chord running this way, and against that chord you've got your perpendicular bisector, which is actually running from the centre down that way. Okay, now I mean it could run all the way down, it doesn't matter, it could be all the way down, it could be from the centre down. those two sides there, the yellow and the red, that's two sides of your triangle. So your third side of your triangle is going to join those two together, and it's a radius because it is from the centre of your circle out to the edge. Okay, your triangle should be fairly easy to spot once you can sort of say, well, there's two sides there. So what we wrote down earlier was that our radius was 11. So that line that I just drew in there is 11. Okay, so what you have now is you have a triangle with the side that's labelled as D, the 11, and then you have this side down here. Now that wee side on the left there that I'm just drawing over in red, that's obviously half of your chord. Okay, so that side there would be 6 because the whole thing was 12. Now that you've got your little triangle, some people quite like to sort of take that triangle out to the side and just draw it on its own. If you want to do that, you absolutely can. If it helps to take it out of the picture, then that's fine. So now we're going to do d squared equals, now that's a short side, so it's 11 squared minus 6 squared. So 121 minus 36. So d squared equals 85, and then square root, so square root of 85, which is going to leave us with 9.2. Okay, so for the lesson today, I want you to kind of take your time with this and be careful with reading the written questions and putting the right numbers onto your diagrams. Okay, so in your booklet, I'm not sure which page it is in terms of how many pages long the booklet is, because I don't have an actual paper copy in front of me. But the page that you are looking for at the top left of the page says page 190, exercise 14.3. There'll be loads of questions running down the page with pictures of circles. You should be able to spot it fairly easily. Now, what I would like to do is we're going to do this today and tomorrow. So for today, the first 5 questions should be plenty. You might not get through all of the first 5, but just start working through those questions, and make sure you draw out a picture to then fill in the values onto. It will make things a lot easier. Please don't try and do this in your head. Draw the triangle out, draw the circle out, fill in what you're told, and then go from there. Okay, so I will check in with you guys again tomorrow. We will do some more of this tomorrow. I'll do some more examples, but please, for today, if you're stuck, ask the teacher that's available to help you, or ask each other and work with your peers. That's fine to do as well. And I will speak to you all in the next lesson video tomorrow. All right, have a nice day, everyone. Thanks. Bye.